On Isaac Physics last week, we had a look at the question, calculate the resultant force acting on a sailing boat if an easterly wind provides 2.5 kilonewtons of force, the tide provides 1.2 kilonewtons of force from a direction 30 degrees more northerly than the wind. And so we had to look and find a resultant force from this, and it did tell us that we should do a scale diagram. Okay, so if we were doing the scale diagram, first thing we need to do is draw a vector to represent the easterly wind. So the easterly wind is 2.5 kilonewtons. So we could use 25 centimetres, but I probably wouldn't have enough paper. So I'm just going to use 2.5 centimetres, looks a little bit too small, but we'll have a go with that because you'll be able to see it on the video, and then we'll, actually if I use 5 centimetres that would work, wouldn't it? So I'm going to draw a horizontal line 5 centimetres long, and that's going to represent 2.5 kilonewtons. Okay, now that is an easterly wind. So an easterly wind actually blows from the east. So that's going to be in this direction here. Now the other force was the 1.2 kilonewtons of force from a direction 30 degrees more northerly than the wind. So what that vector is going to look like, it's going to be 30 degrees more northerly. It's going to be sort of in a direction like that where that's 30 degrees, okay? And because it's 1.2 kilonewtons, we're going to need to make that 2.4 centimetres long. Okay, so if I'm going to be adding together these two vectors, I've got to draw one of them, which I've already done here, and then I'm going to have to draw this one, this 2.4 centimetre one, at the end of that one at an angle of 30 degrees, okay? So it's 30 degrees, if I just sort of sketch a line there, it's 30 degrees there to the horizontal, so this is going to be 30 degrees below the horizontal. So if I just extend my line there by a little bit, okay, so I've got an angle to measure from, and I'll use the protractor, and I want it to be 30 degrees below, so 10 degrees, 20 degrees, 30 degrees below, it's going to come off in this direction here. So I will put my line in. So I'm drawing a line in that direction. That's far too long though, it needed to be 2.4 centimetres long, so if I just mark that off, 2.4 centimetres is around there. That's the force from the tide. So my resultant, that one should end at that point there. You start at the start of the first one, you end at the end of the last one, it's that direction there. And we find out, if I measure that, it looks like it is approximately 7.4 centimetres long. So this one's 7.4 centimetres long. To work out what that would represent, 7.4, divide that by 2, I believe it should be 3.7 kilonewtons. So that's one way of doing it. Other way of doing it is using your maths, okay? And you're all good at maths. You may have come across the cosine rule, the sine rule before. So have a think of this, this triangle here. If I know that that angle is 30 degrees, I know that that angle is 150 degrees. So if I'm wanting to try and work out what the resultant is, I just sketch it a bit clearer. I've got this is 2.5 kilonewtons. I've got that 1.2 kilonewtons. I know that that's 150 degrees. I want to know the length of this side. Could you do it using your maths skills?